Have you ever wondered about the chemical messengers that mediate various physiological and pathophysiological responses in our body? These messengers, known as Autacoids, are a fascinating group of bioactive substances. They're like the secret agents of our body, working behind the scenes to maintain balance and respond to changes. From regulating blood pressure to mediating inflammation, these substances play a critical role in a multitude of physiological functions. They're produced locally, act locally, and are metabolized locally, a perfect example of self-regulation. We'll be exploring several types of Autacoids in this series, including histamine, 5-HT, kinins, prostaglandins, leukotrienes, platelet activating factor, angiotensin, and their respective antagonists. Each of these Autacoids has its unique role in our body's functioning, and understanding them can provide insights into how our body responds to different situations. Now that we know what Autacoids are, let's delve a little deeper. How are these Autacoids produced and released within our body? A compelling question, isn't it? Let's dive into it. Autacoids, also known as local hormones, are synthesized and stored in our body and are released in response to various triggers. They are bioactive substances with a local effect and do not require to be transported by the circulatory system. Now, how exactly are these Autacoids synthesized? Well, the synthesis of Autacoids is an intricate process that involves several enzymes and cells. The process begins with the conversion of arachidonic acid into different Autacoids like prostaglandins, leukotrienes, and thromboxanes. This conversion is facilitated by two primary enzymes: cyclooxygenase, which aids the synthesis of prostaglandins and thromboxanes, and lipoxygenase, which assists the synthesis of leukotrienes. Histamine, another prominent Autacoid, is synthesized from the amino acid histidine with the help of an enzyme called histidine decarboxylase. Similarly, serotonin, also known as 5-HT, is synthesized from the amino acid tryptophan through a multi-step process involving several enzymes. Once synthesized, these Autacoids are stored within the cells in vesicles. This storage is an essential step as it allows the body to have a ready supply of Autacoids for immediate release when required. The release of Autacoids is triggered by various stimuli, such as tissue injury, allergic reactions, or inflammation. Upon stimulation, the Autacoids are released from the cells and act locally to modulate physiological responses. For instance, histamine released from mast cells during an allergic reaction leads to the classic symptoms of inflammation, redness, heat, swelling, and pain. Understanding this process is crucial to appreciate the role Autacoids play in our body. They are not just chemical messengers, but pivotal players in the body's response to injury, inflammation, and other physiological processes. So, next time you experience an allergic reaction or inflammation, remember it's your body's Autacoids at work. So, what happens once these Autacoids are released into our system? Well, Autacoids play a significant role in maintaining the physiological balance in the human body. For instance, they have a hand in regulating inflammation. When tissue damage occurs, Autacoids such as histamine, kinins, and prostaglandins are released. These substances cause the blood vessels in the surrounding area to dilate, leading to redness and heat. They also increase the permeability of these vessels, resulting in swelling. This entire process is known as inflammation, and it's a crucial part of our body's defense mechanism against injury and infection. In addition to inflammation, Autacoids are also involved in allergic reactions. When an allergen enters the body, it triggers the release of histamine from mast cells. This histamine then binds to receptors on other cells, causing symptoms like itching, redness, and swelling. These are the symptoms we commonly associate with allergies. Now let's shift gears a bit and talk about gastric secretion. Autacoids, particularly histamine, play a vital role here as well. They stimulate the secretion of gastric acid in the stomach, aiding in digestion. However, excessive secretion can lead to conditions like peptic ulcers. But it's not all roses with Autacoids. They also have pathophysiological roles, meaning they can contribute to disease states. For example, overproduction of certain Autacoids such as leukotrienes and prostaglandins can lead to chronic inflammatory diseases like asthma and rheumatoid arthritis. Similarly, an overactive histamine response can result in severe allergic reactions, also known as anaphylaxis. So, as you can see, Autacoids are like double-edged swords. On the one hand, they help our bodies respond to injury and infection, aid in digestion, and mediate allergic reactions. On the other hand, When produced in excess, or when the body's response to them is out of balance, they can contribute to various disease states. Clearly, autacoids have a broad range of effects on our bodies. Let's start with one of the most well-known autacoids, histamine. This biogenic amine is synthesized from the amino acid histidine through the action of the enzyme histidine decarboxylase. Stored in cells like mast cells and basophils, it's released in response to various stimuli including allergens, tissue injury, and certain drugs. Physiologically, histamine plays a vital role in many bodily functions. It's a key player in the immune response, dilating blood vessels and increasing vascular permeability to allow immune cells to reach the site of an infection or injury. It also regulates gastric acid secretion, acting as a paracrine signal in the stomach. However, in pathophysiological conditions, histamine can become a troublemaker. Overproduction or inappropriate release of histamine can lead to allergic reactions, causing symptoms like itching, redness, swelling, and even anaphylaxis in severe cases. Now let's talk about histamine antagonists, or antihistamines. These medications work by blocking the receptors that histamine binds to, thus preventing its effects. First-generation antihistamines like diphenhydramine can cross the blood-brain barrier and cause drowsiness, while second-generation antihistamines like cetirizine are less sedating. Antihistamines are commonly used to treat conditions like allergies, hay fever, and even insomnia. So that's histamine for you, a key player in our immune response with its dual nature of being both a protector and a potential provoker. Moving on to another vital autacoid, 5-HT or serotonin. This fascinating molecule is synthesized from the amino acid tryptophan. Following a two-step process, tryptophan is converted into 5-hydroxytryptophan by an enzyme called tryptophan hydroxylase, and then into 5-HT by decarboxylation. This synthesized serotonin is stored in vesicles within the central and peripheral nervous system. Release of serotonin occurs in response to various stimuli, like light, food, and stress. Once released, it binds to specific receptors, initiating a cascade of events that influence numerous physiological functions. Some of the key roles of serotonin include regulation of mood, appetite, sleep, and even learning and memory. Now, isn't that intriguing? However, an imbalance of serotonin can lead to pathophysiological conditions. Too much can lead to a condition called serotonin syndrome, characterized by agitation, restlessness, and rapid heart rate. On the other hand, too little is linked to depression and anxiety disorders. Enter the 5-HT antagonists, the heroes that help maintain the serotonin balance. These drugs, like selective serotonin reuptake inhibitors or SSRIs, block the reuptake of serotonin, making more available in the brain. This can help alleviate conditions like depression and anxiety. In a nutshell, serotonin is a crucial autacoid with a profound impact on our well-being, from our mood to our sleep. Its antagonists play a vital role in managing conditions arising from serotonin imbalance. Serotonin, a crucial autacoid regulating our mood, and much more. Let's not forget about the other important autacoids. Firstly, let's delve into kinins. These are polypeptides synthesized from kininogens through the enzymatic action of kallikrines. They are involved in numerous physiological processes like vasodilation, inflammatory responses, and pain induction. Kinin antagonists are used to manage conditions like hereditary angioedema, where excessive kinin activity is observed. Next up, we have prostaglandins. These are derived from arachidonic acid and have diverse physiological roles, including regulation of inflammation, gastric acid secretion, and platelet aggregation. Prostaglandin antagonists, commonly known as non-steroidal anti-inflammatory drugs or NSAIDs, are frequently used for pain relief. Leukotrienes, another group of autacoids, are also synthesized from arachidonic acid. They are involved in bronchoconstriction, increased vascular permeability, and leukocyte chemotaxis, making them major players in allergic and asthmatic reactions. Leukotriene antagonists are used to manage asthma and allergic rhinitis. The platelet activating factor, or PAF, is a potent phospholipid mediator involved in platelet aggregation, inflammation, and anaphylaxis. Antagonists of PAF have been developed to treat conditions like asthma, septic shock, and ischemic stroke. Finally, let's talk about angiotensin. This peptide hormone plays a crucial role in regulating blood pressure and fluid balance. It constricts blood vessels and stimulates aldosterone release, leading to increased blood pressure. Angiotensin antagonists, including angiotensin-converting enzyme inhibitors and angiotensin receptor blockers, are commonly used in managing hypertension and heart failure. Each of these autacoids, though they may seem less known, play significant roles in our body's functioning. They are involved in a wide array of physiological processes, and their antagonists are vital tools in pharmacology, helping us manage a variety of pathological conditions. Understanding their roles and how to modulate their actions is key to developing effective therapeutic strategies. These autacoids, though less known, play significant roles in our body's functioning. So, we've covered quite a bit about autacoids today. We've journeyed through their synthesis, storage, and release, and delved into their physiological and pathophysiological roles. We've unearthed the mysteries of histamine and 5-HT, along with their antagonists. Not forgetting, of course, our exploration of other autacoids like kinins, prostaglandins, leukotrienes, platelet activating factor, and angiotensin. It's a fascinating world, isn't it? Remember, knowledge is power, and there's always more to learn. Subscribe for more because you won't find me later.